This is Greg Troutwine with Maritime Reporter TV, and we're here in New Orleans at the International Workboat Show, and we're very pleased to be in the Regal Rexnord booth with Bob Lennon of Regal Rexnord, Matt Combs, Christie and Gray, Jesse Spence, Noise Control Engineering, and we're here to talk about modern drivetrains and specifically drivetrain technology and how important it is to start at the beginning of the design process. So when the boat comes out, you get what you paid for. So Bob, can you just start us off? I mean, we had a conversation in your headquarters a few months ago, and we were talking about the importance of starting early on drivetrain design and planning. Why don't you just give us a brief recap of the importance of the whole topic?
Yeah, happy to. You started right off with the message. Engage the experts as early as you can. It's just like that torsional vibration analyses process we talked about before. The earlier you can get the experts engaged in these projects, the better your outcome's going to be. The more specific topic here now is about noise and noise propagation out of a boat. There's a clear need in the industry, and it may vary by vessel owner. Jesse can talk more to that. But there's a lot of boats out there that they want to have as quiet as possible. In my mind, it might be a tugboat and it might be operator comfort. Maybe it's a research vessel and it's propagated noise to the water. But the clear message is to get your experts onto your project as early as you can, because then guys like Matt and I can do our due diligence and make sure his product's going to play with my product, and the system is going to do what Jesse wants it for the end customer.
Okay.
So there's the synopsis.
I love the synopsis. So Matt, if we can just turn to you for a moment. We talk about digitalization and information, the need for correct information, and I would assume from engineered solution that correct information at the outset is imperative. So when you look at mounts and couplings, what are the critical bits of information that you need to know at the beginning?
We need to know about what the technical aspects of the equipment are. Its performance characteristics, its dimensions. It's all about geometry. It's about forces, dynamic forces. And we want to work so that we know what the coupling is doing, because everything interacts. The mounts itself are the foundation. And every part of that system, including the pipe work, the drive couplings, everything interacts with the mounts, and they set the pace. And if the mounts are wrong, then everything else will be affected. So coordination and proper engineering, proper weights, weight distribution, where the equipment is in the vessel are all critical factors that we use to do our calculations.
Okay, so what specific calculations then are needed from the start?
What we do is a 6 degrees of freedom calculation, and what it does is it drives out the performance character, natural frequencies in the system, and the performance character, how much the thing is going to move, in what direction in a seaway, how much it's going to move as a result of the actual performance of the equipment, engine torque, and so forth. And again, it goes back to the coupling. That interaction drives through the coupling. So it directly affects our equipment, and we directly affect his equipment. So if we don't do a good job of it, then you can end up with problems where you actually amplify the vibration as opposed to isolate it.
Yeah. Make it worse instead of better.
And that's bad in engineering products. So Matt, I'm just going to stick with you for one more, if that's okay. So then, how do the specific CENTA calculations differ from the CNG calculations?
They do torsional calculations, which is rotation, and we do dynamic. We do isolation of forces going into structure and through pipe work and so forth. And it's not the same. Torsional is totally different. It's about rotation, and we're about statics and dynamics.
Yeah. Different yet symbiotic in their relationship to one another.
Exactly.
In terms of the performance of the whole package.
The whole package is designed to keep those forces from going from the equipment to the vessel. If you think of the whole system, the exhaust pipe work, drive coupling, engine mounts, they're all isolators, they're all blocks. You're trying to control that energy and keep it from propagating up to the vessel.
Yeah, that's excellent. Again, I appreciate all of your insights. So, Jesse, you come in at the end.
Yes.
And you basically are there to ensure that what was designed what was built, what was installed, is working as it should be or as it was intended. So what data are you collecting specifically to make sure that the system is working as it is intended to be?
Sure. Well, so at the end of the process, it's the proof is in the pudding. So does the vessel meet its noise and vibration requirements, right? So we're getting on board during sea trials and performing airborne noise measurements, performing vibration measurements, making sure people's fillings aren't getting shaked out and everything. So we really are, at the end of the process, we're there to make sure that everything has gone correctly. And that's where, the proper engineering that's been done up front is really, that's where it shines through. That's it's all required. I will say, though, that a lot of what we do is also on the front end. So we assist naval architects, vessel owners, and shipyards to make sure that the vessel is designed to be quiet. So a lot of what we do is we're looking at the whole ship design, so not just the mounting of the systems, the engines, but also how is sound and vibration traveling throughout the entire ship, making sure that we're going to meet the requirements for the vessel. But there again, that's where we're relying on quality products to make sure that we look good, right? So at the end of the day, we are there to help our clients meet a noise and vibration goal. And we like to select components that are going to get the job done and do it well. And that's why we've had a long, excellent relationship with both Christie and Senta. And, we really appreciate the fact that they have a focus on quality, a focus on performance, and they do the engineering up front and help us look good, really.
I could use anyone that helps me look good.
That's right.
I appreciate
all
that
of us.
very well.
Yeah.
So Jesse, let's kind of get down to basics. I mean, what equipment do you use? How do you gauge the noise on board?
Yeah, well, so it's pretty simple, actually, as far as the ultimate measurements are concerned. Microphones, accelerometers, even underwater noise. We're out there and collecting data with hydrophones, put them in the water, and make sure if there's underwater noise requirements that everything meets that way. But again, on the front end, we're using advanced techniques to perform predictions before the vessel is even constructed. So whether it's finite element analysis, statistical energy analysis, just empirical methods, or our just 30 plus years of know-how, we are looking at the design, making sure that the right steps are followed in order to meet the requirements. And it all starts at the source, right? So if the engine isn't mounted properly, if we don't have the right coupling on the shaft line, there's a problem. Right, and sometimes we have to account for those problems if it's not the right system, or for whatever reason that might be. But when we're using these guys' products, it's we have a level of comfort that we can move forward maybe with reduced treatments elsewhere in the ship.
That's excellent. I personally, I've been doing this for 33 years myself.
Yeah.
And I walk around these halls, you see a lot of familiar faces, a lot of new faces increasingly these days. And I know specifically it's not always the easiest to talk about the boats and the projects, because I know a lot of vessel owners don't want the information on their vessels public. But can you share with me, any of you, details on one project, even if you're not naming names, just a project that you really highlights kind of the combination of Senta and the Christie and Gray?
Yeah, I would say, so we were actually just discussing the island home, which is the Martha's Vineyard Ferry. It's been quite a number of years since that one was delivered, but honestly, that was a great project for us. I believe it was one of the first vessels of its type that had actual resiliently mounted engines. It was a lot of discussions with the owner to make sure that they were comfortable. We said, no, this is something that can be done. And Matt came in and assisted with those conversations as well. And at the end of the day, the vessel came out, it was just fantastic. I mean, people comment that they can't even tell that they're leaving the dock because, they can't hear the engines. It's truly an amazing ship. And that was an early one for me personally, but yeah, it was a great success.
The question begs, you're telling everyone, get involved early, get us involved early. How prevalent is that? Is that the norm? Is that the exception? Are we somewhere in between? And I'm not looking to get you to lose any customers, so you don't have to name names. But
I don't want to laugh on camera, but we're probably somewhere in the middle.
Okay.
Recently did a webinar on the torsional subject, and we did some polling questions, and that was one of them. How often are you engaging the experts up front? And it really was about a 50-50. I'd imagine we'd get similar results on the noise side of it.
Yeah.
It's important. It's a valuable asset. It's a lot of money. And at our level of the component price into the asset, we're nothing. But if we're wrong, he's going to be looking at the boat later going, why did you do this?
Yeah.
So it's low cost, but it's big value add. But if we're not on early, the worst thing can happen is somebody comes with a design done and we're looking at it going, yeah, well, our stuff's not going to fit.
Yeah.
So that's the big message. Be early, be proactive.
Fix it in the design phase, and don't try to remediate, because it's going to cost 10 times as much.
Yeah.
Absolutely.
Love to have a shipyard here to talk to us about cutting out rails to change to soft mount engines late in the build.
Well, actually, to that point, I mean, we do a lot of diagnostic testing. Hey, my boat's been vibrating since day one. We're finally fed up with it. Or we've got these noise issues. And sometimes they're hard conversations because it's like, look, your options are pretty limited. You've got this boat that already exists. You haven't looked at this from the beginning, and the outcomes are just going to be much, much better if you can start before the vessel has been constructed.
Yeah.
Really do the proper engineering up front and design it right.
Okay, well, Bob, maybe that could be our evolution. We started with you in Regal Rexnord headquarters in Milwaukee. We continued with the Meet the Experts here on the ship floor in New Orleans. So maybe next time we'll drag a shipyard in, and we'll get that perspective as well.
Yeah, get more of the message out on the street. Be great.
Absolutely.